Okay. Professor Leah Fostick is an experimental psychologist. Her studies focus on auditory perception and psychoacoustics in different populations, such as aging, dyslexia, ADHD, and sleep deprivation, along with the studies in psychiatry. She completed her PhD in psychology in 2006 in the field of psychoacoustics and auditory perception. During this period, she was the study manager of the Department of Psychiatry in Qaim, Sheba Medical Center, Israel. Since 2007, Professor Fostick works in the Department of Communication Disorders at Ariel University, Israel. She was part of the department's founding team and also founded the Auditory Perception Lab. Today, Professor Fostick heads both the department and the lab, teaches psychoacoustics and research-related courses, and instructs graduate students. Thanks a lot, Leah.
Thank you. I'll share my presentation. So, hello from Israel. It's now 4:15 p.m., quite comfortable. I would like to thank the organizers for this meeting and dive into my presentation. I'm going to talk about the effect of music tempo and tonality on speech perception. Let me share just a second the computer sound, okay? And now I'll give you a small task. So you see this person. I'm going to show you a clip with accompanying music. And please look at this person and think, what is going to happen to him? Where does he go? What does he think? So here we go. Okay, so this is this person again. I'll show you a different clip of him going, and please think again. What is going to happen to him? What does he feel? What does he think about? Here we go. Okay, we saw the same clip twice, but the background music made us feel differently and then think differently on the same person in the same situation. In other words, the different auditory information made us interpret differently the visual information, although it remained the same. And what would happen if under different emotions, we will need to make decisions, memorize, process information? Pay attention to this tune and think, what does it make you feel? And this tune. So you probably figured out that these were the same tune. That was same tunes that were played in different tonality, major versus minor, and in different tempo, fast versus slow. The different acoustic cues affect the emotion we perceive. The tempo, slow tempo, makes us feel more sad, melancholic, and fast is related to happy. The tonality is very famous, with minor related to more sad and melancholic emotions, and major with the more happy ones. The intensity of the sound, there is a mix here. The high is with the happy and the low is with the sad. And the frequency of the tones. The high frequency is related with the happy and the low frequency with the sad. I'm sorry about the mix mixing here. So different acoustic cues can be related to different emotions or different emotional influence. The details that I put here on the slide simplify the picture. It gives a very general picture of the relationship between acoustic cues and emotions. It is correct, but you should consider it very simplified, because as with emotions, the picture is always much more complicated. This is Charles Limb, an ENT, works with cochlear implant patients. He and his group tested how we perceive different combinations of tonality and tempo. They gave their participants tunes in 4 combinations of major and minor scales and fast and slow tempo, similar to what I played before. They asked their participants to rate the valence of the tunes. So you can see here the rating of the valence. On the y-axis, you can see the valence rating. On the x-axis, you can see the tempo. And we have black bars and gray bars for the major and minor tonality. As then you can see here, fast tempo and major tonality receive the highest valence, which means more happy. Minor tonality in slow rating received the lowest valence rating, which meant towards sad. The 2 other combinations, minor tonality with a fast tempo or a major tonality with slow tempo, received inconclusive rating. They were rated close to 0, somewhere in between sad and happy. We call them neutral or control. Interestingly, patients with cochlear implant that were asked to rate the same tunes rated them according to the tempo. Both fast received a similar valence rating of happy. Both slow tunes received a negative valence rating without relation to the tonality. This is in accordance with cochlear implant users' hearing difficulties, that the cochlear implant is not very accurate in perceiving frequency, but it is okay with perceiving tempo. And you can see here that the tempo affected their valence rating and not the tonality. But this is for a different study, and I am focusing on the ratings of the control participants. So let's consider again our tunes. If I will play them during my talk, they will affect the way you will perceive or understand me. This is, of course, because they will mask a little my speech. Whenever you have 2 competing acoustic signals, one is interfering with the other one. So if I will play the tunes during my talk, they will mask me, at least partially, and will affect your ability to understand me conveniently. However, I also ask whether the effect, the factor that will affect your perception of my talk will be only the acoustical masking, or whether it will be also the emotion that you will get from the tunes that I will play. So this is the question of the present study, and we aimed to test whether music related emotional state will affect the speech perception. So we hypothesized that speech perception, the ability to perceive speech, will be better with happy-related background music, which is comprised of major scale and fast tempo, and it will be poorer with sad-related background music, comprised of minor scale and slow tempo. So in this study, we had 30 students aged 20 to 25 that were screened for good hearing, and they did a speech perception task. The speech perception task included 20 lists of 10 words, 2 lists for each condition. The words were monosyllabic consonant-vowel consonant word, meaningful in Hebrew, and all the lists were phonetically balanced. We used the music of Charles Limb and his colleagues, and we had the same 4 combinations, major and minor scales, fast and slow tempo. So we had 4 conditions. We had the major fast, which was happy, the minor slow, which was sad, and 2 control conditions, which were the mix, the major slow and the minor fast, that received neutral or the neutral ratings. We played the words and the music in 5 signals to noise ratios. We wanted to manipulate the difficulty of the task, and therefore we gave them in signal to noise ratio of 0, which is which means that the level of the words and the music are the same, to minus 15, which meant that the music was louder in 15 decibels more than the speech. So the words and the music were played simultaneously. It was within subject design in 2 sessions, one for each emotion and the control. So they came, they did happy and control, and they came again and they did sad and control. This was intermixed within subject. And here are the results. So you can see here the results of the 4 conditions. On the x-axis, there is the different 5 signal-to-noise ratios, and in the y-axis, the percent correct of the words. You can see that as the signal-to-noise ratio got more negative, the accuracy decreased because the task was more difficult. The noise, the background music was louder, and it was more difficult to understand the words. Sorry. So if you look here on the 2 straight lines here, the blue and the red, the upper 2 lines, you can see the 2. Sorry. Actually, I think I will skip this, and I'll show you the results in a better way to perceive it. Only before it, I'd like to show you that we got actually a ceiling effect in the 2 easiest conditions. The signal to noise ratio of 0 and -5 received very high results, accuracy results. So we took them out of the analysis. So this is the data that we eventually analyzed, the 4 conditions in 3 signal-to-noise ratios. And here are the results more focused. You can see here the effect of the signal-to-noise ratio, and as expected, as the signal-to-noise ratio became more negative, there was a decrease, significant decrease in the accuracy of the words. This is because we had an acoustical masking. The more louder the music was relatively to the words, it became more difficult. It masked the words, and it became more difficult to perceive them. This is the effect of tempo. You can see that the slow tempo resulted in higher accuracy rate than the fast tempo. Here again, we can explain this, this result in an acoustic factor, because the fast condition, when the music is fast, you have more energy. When the music is slow, you not only have less energy, but you have larger breaks within the music. You have longer sounds. You can adapt to them in a very short perceptual learning. So the slow, they are both masking the speech, but the slow tunes are a lesser masker than the fast tunes. And you can see this in the results. And last is the tonality or mode effect, the major versus the minor. So you can see in the major, it's actually the two different tempos are averaged for each tonality, and you can hear the effect of the major versus minor. And you see that for the two most difficult SNRs, there is a significant effect, and participants had better accuracy rates for when the major scales were played than the tunes in minor scales, which was actually the question of the study. So to summarize everything, we had an acoustical effect, we had a masking effect according to the signal-to-noise ratio. We had some limitations here. We received the ceiling effect in the easier SNRs. And but we already had masking effect according to tempo, which was quite acceptable. But we also had an emotional effect. The performance accord with the musical related emotion. As we expected, we received higher accuracy rate for tunes in minor scale, tunes that were related to happy emotion, than the tunes that were related to sad. The limitation here that this effect was quite subtle. We only received it for the most difficult signal-to-noise ratio, for the most difficult conditions in the study. So we received like a ceiling effect for this effect, or this effect might be delicate, and we can see it only in very specific conditions. So we can add to all the functions that are affected from emotion, also speech perception. And this is very important because also clinically, because when participants get to the clinic and get their hearing tested, then maybe the emotion, I don't think it will move them from having a good hearing to poor hearing, but subtlety, it can move them for near hearing disability to have it. I mean, those with good hearing might not be affected from any emotion, but those with very marginal hearing can be affected from it. And of course, we can take it to other functions and also conclude about the mechanisms, because speech perception is quite a basic task. And usually when we talk about the effect of emotion on our functions, we deal with more complicated judgments and tasks. And here we can see this effect on more basic tasks. Okay, and this is it. I want to thank my colleagues and the students and everybody who was involved in this study. And thank you for listening.
Oh, sorry, I was on mute. Thank you, Leah. That was a really interesting talk. We have a couple of questions. So The first one I kind of want to put to you is, obviously there's a lot of cultural differences in music. So we have a question here: how generalizable is the notion of major versus minor across cultures in terms of emotional outcomes, as different harmonic norms characterize the music in different cultures differently? So do you have any insight into that?
It's probably cultural, and major and minor, we see it in the Western music, but different culture have definitely different different definitions, and I can predict that if not major and minor during the effect, then the other cues for different emotions are doing it.
Mm-hmm. Okay. Sorry, it's really hard to divide your attention between the questions that are coming in. So another one is asking for a little bit of clarification about how you're defining intensity and whether you're basing that purely on the dynamics of the music or not.
Okay, so in this study, we didn't manipulate intensity as an acoustical cue for emotion. We manipulated it for as a signal to noise ratio related the speech, the target relatively to the background music. And how we manipulate this, I mean, I'm not sure I understood the question. I mean, we measured the intensity level of the music and the speech and just manipulate it accordingly.
Okay. So we have one here about kind of the specific keys in music. So do you know if the effects differ according to particular keys as opposed to major and minor, for example, in B minor compared to G minor?
Okay, I don't know. We don't have any kind of information. I don't see it also in the, well, there is some studies in the literature, quite old, I think, that try to differentiate, and there is some slight differentiation between different keys, but not as much as between major and minor.
Okay. We have one here about speech. So could results comparing major and minor background music partly be explained by similarity with speech prosody, i.e. would one or other stand out more against speech and therefore make understanding of it easier or not?
Oh, this is a very interesting question. We tried to control this effect and therefore we used only words and very short ones, consonant vowel consonant words, monosyllabic words, very short words, in order not to also mix this factor within. But it's very interesting that some of our sentences might be perceived in different emotion due to the prosody or intonation that we use. And I think that sometimes we perceive different people as having different emotions. And in some cases, it might be due to the intonation that they use.
Okay. A group of people are asking more about your sample and whether they had any musical background, whether you asked that, and also whether you think that would have an influence on how it affects speech, whether a person does have a musical background or not.
So the samples that we used have no or minimum. I mean, I don't think that most of them have had minimum musical background. They were not musicians. They mostly had music education when they were children, but did not engage in musical activity in the last 5 years, at least. At last 5 years prior to the experiment.
Great, thank you. So some group of people have asked as well about how their understanding of whether major music is always happy and minor music is always sad. Is there also cases when minor music can also be considered to be happy and pleasurable to people? And did you have any insight into that?
Okay, so I warned you that it was very simplified, and of course the picture is more complicated. If you take the music and you put it in a context, you put it with a rhythm. If you the different cues play together. So if you take a minor scale, but a fast tempo and the high intensity and the high frequency, it will take the tune towards the happy side. If you take a major scale and you put all the other cues towards the sad, it will take the tune towards the minor. It's a continuity, and it is affected by several factors which work in combination.
Great, thank you. So we have another one here. Major notes are more common than minor in Western music. So is it just easier to ignore the more common major scale in noisy environments so that we can concentrate more on the words being presented to us? Is that a potential influence?
It can be. I can say that I mean, in Israel, the national anthem is in minor scale. It's very unusual. Usually the national anthems of different countries is in major scale and is very upbeat. And in Israel, it's a bit melancholic. So it can be that as we hear more major music that we are used to so it makes us more easy. It makes it more easier to understand the speech with major tone, but I don't know. I mean, I don't know if major scales are really more common. There are a lot of melancholic songs. There are people who like to hear melancholic music. So I don't know. It can possibly a possible explanation, but I don't know if this effect is so large. Great.
So you mentioned very briefly at the end the kind of potential therapeutic benefits of this kind of research. So is there any kind of specific direction that you're hoping to put this research into the therapeutic kind of world?
So currently we are replicating the study, and we're also doing a second study with dissonant and consonant music to see if the pleasurable feeling can be also an effect on the speech perception, on the perception itself. But when replicated and with more studies, I think that we can make some recommendations for clinical setting about the emotional state of the patient. I mean, or maybe to repeat their diagnostic sessions, to have their patient in different moods. If the patient receives bad results or good results, let them, mostly bad results, let them sit down a bit, relax, maybe then repeat. I mean, with more studies, if we get the same results, I think that recommendations can be to clinical settings can be set.
That's great. Thank you so much. I think we'll have to leave the questions there. Thank you so much again. And if I didn't manage to get to your question, I'm sorry. And they'll also be recorded and sent to the speakers afterwards. So
thank you very much.
Thank you.